So here's an example for the intermediate value theorem. Let f be a continuous function on the closed interval -2 to 7. If f of -2 is 5 and f of 7 is -3, then the intermediate value theorem guarantees which of the following. So we know that the intermediate value theorem basically is going to tell us, so this function is continuous from -2 to 7, and we were given that f of -2 is 5, so there's some point up here at 5, and then f of 7 is -3, so somewhere down here at -3. These are the values of the function. Now since the function is defined between the 2 points, it can take any shape. I'm just drawing a possible example. So what the intermediate value theorem guarantees is if we pick any y value between -3 and 5, so anything between here, we will find an x value between -2 to 7 where the output of the function would correspond to that value. So we can eliminate both options A and B because those are talking about the derivative, and the intermediate value theorem has nothing to do with the derivative. Now, f of c is equal to 0 for at least one c between -3 and -5. Well, the value of c is somewhere along the x-axis. So -3 and 5 are the y bounds. So that is not correct either. So the answer is D. F of c equals 0. So first of all, 0 does in fact lie between 5 and -3. So for 0, there exists some c. So in this case, we're talking about a c value for y equals 0. So there exists some x value between -2 to 7 such that f of c is going to be 0. So D is the correct answer.